Hi guys, this is Module 2.2, and today we're going to be learning about evaluating expressions and functions. So two major ways that we're going to get started. The first is by figuring out what to plug in, and the second is going to be simplify. Okay, so two steps as we go today. Okay, so we're going to start with evaluating expressions, and what we'll see is we'll just see a problem or an expression, and then it'll ask us to evaluate it given a couple pieces of information. So if we see the letter A, we're going to plug in the number 5. So anywhere we see it, we're going to plug in the number 5. And that's going to play out throughout. So anywhere we see the letter B, we're going to plug in -3. So here and here. Anywhere we see the letter C, we are going to plug in the number 2. And anywhere we see a D, we're going to plug in a -4. So as you can see, this looks like it's going to get a little out of hand, but we got this. So I'm going to draw my long fraction bar. I like to set up like an empty problem. And when I set up that problem, I know I'm going to have a long fraction. And then every single time that I plug something in, I'm going to use parentheses. So here I'm looking for A, that's 5. And then I have my parentheses for D, which is -4. I'm going to copy down that minus, and I'm going to plug in B, which is -3, and I'm going to plug in C, which is 2. Notice that I use parentheses around everything that I plug in, super important. And then on the bottom I have A, which is 5, plus B, which is -3. From there, I'm just going to simplify using my order of operations that we practiced yesterday. So I know that 5 times -4 is -20. I'm going to leave that subtraction. And I know that -3 times 2 is -6. Right, so I have that in parentheses. And then on the bottom here, I have 5 plus -3, which I know is 2. Right, I'm going to simplify the top, so I have -20 plus 6 over 2, and then finally -20 plus 6 is -14 over 2, which will simplify to -7. Okay. So we just plug in the right numbers, and then we simplify. That's it. So if we're looking at a second example, I'm just going to write my empty problem again. I'm actually just going to rewrite the problem. The reason I'm doing this is just so that I can really organized in my root. So I see a couple x's, so I'm going to replace those x's with the number 9. Right, replacing those with the number 9. And then I see 1y, so I'm going to replace that with a 1. From there, I'm going to fill in the rest of my problem. So I see the parenthesis, a minus and a parenthesis, a minus, a cube, and 2 parentheses. From there, I just want to start and make sure that I am using my order of operations. So I'm going to do 1 to the 3rd first. That's going to be 1. The rest of my problem, I'm going to write in 9 minus 1. I'm going to fill in the beginning part of this problem here. Following my order of operations, I'm working inside. So that means that 9 minus 1 is 8. I have the beginning of my problem again. The inside my parentheses here, 9 minus 8 is 1. And I have 9, and 9 minus 1 is 8. Right, so we get our final answer. Okay, so now we're going to look at evaluating functions. And when we evaluate a function, we're going to use function notation. And that function notation is f of x. And f of x is just the name of the function. We might as well name it Francine or Frank. But f of x is just the name. You could use any letter, a of x, p of x, q of x. F of x is the most familiar one. And then the x, so the f would be the name of it, and the x would be the input, or what we're going to put into the function. Right? So when we put that number in, that's going to be the number that we plug into the function. Okay, so this problem very similar to the ones that we've been doing, just a little bit worded differently. So it's going to give us a function. It's going to tell us that f of that number of f of x, or the Francine function, follows this rule. So this will be the rule 7 minus x over 16. Then it's going to ask us to evaluate for that number for a particular x. So when we plug it in, we're just going to say f of 32. We're trying to find out where the function is when x equals 32. So anywhere we see x, we're just going to replace an x with a 32. So I'm going to pull down my original function, f of x equals 7 minus x over 16, and instead of that x, I'm going to write the number 32. From there, I do still want to use my parentheses, just in case, and from there, I'm just going to simplify and evaluate it. So I have 7 minus my 32 divided by 16 is 2, and then I have 7 minus 2 is 5. So I would know that the function at 32 is 5. My final answer would be 5. So again, we see just two things. We're going to plug in, and we're going to simplify. Those are our two rules today. So plugging in, simplifying our steps. Okay, so in this problem, we just have a couple more here. So we have f of x equals this. This is our rule. So when we're finding f of 4, right, we're going to, anywhere we see x, we're just going to plug in the number 4. So I have my 6, and I have 6 here, and it looks like that x is our exponent, so the number 4 there, and plus 5. So when we solve this, we're going to leave our f of 4. That's not really, doesn't really mean multiplication. It's just sort of saying the function at 4, right? And then we will do our 6 to the 4th power, which we can calculate is 6 times 6 times 6 times 6. So that's going to give us 1,296, and then plus 5. So when I continue to work through my problem, I'll multiply times 6, which is 7,776 plus 5. Continue here, 7,781. Right, so that's going to be our final answer. To finish us off today, we're going to look at one more, slightly more complicated problem. So in this problem, it says if f of n, so remember that's the function at n, or defined by n, if f of n equals n plus 3, what is f of x plus 1? So they give us something here to plug into our equation. They tell us that x plus 1 will be what we're plugging in. So we're going to plug x plus 1 into our problem. So when we write f of x plus 1, anywhere we see n, we're going to write x plus 1. So right here where I see, I'm going to write x plus 1, and then I have my plus 3. So what we're really seeing here is that n plus 3. Right, so from there, it's not really that much more complicated. We just are going to combine our like terms. So we have 1 plus 3, and we have x plus 4. So we can find out that there's no more simplification to be done. It's just x plus 4 would be our answer. If you have any questions, please let me know, and I'm excited to see you in class. Sounds good. Bye-bye.